So today we are going to be talking about the atomic bomb. Like yesterday, this is a little bit of a heavier subject because we're going to talk about, some war crimes. Things we're going to be talking about today. Plenty of three. You can make an argument for the way science is being done is changing because now we're moving from like individual scientist works to like massive projects that involve thousands of people. You could make arguments about number 6 because what happens with nuclear bombs and nuclear fission is we're literally turning matter into energy. 7 will show up, and 9, whose work was essential to the building of the atomic bomb. That's the majority of what we're going to be talking about today. So where we left off, we had talked about Lisa Meitner. We had talked about how she had done, oh yes, Paige?
Is that the or is that
The bomb is the title for today's lesson, yeah. So we had talked about Lisa Meitner, and we talked about how she had figured out that if you fire a neutron at a uranium nucleus, the uranium nucleus will split into 2 smaller atoms, barium and krypton. But that when this happens, a tiny amount of matter actually goes missing. A little bit of matter went missing, and it actually turns into energy. Raise your hand if you've ever heard the equation E equals mc squared. Yeah. Most folks' hands went up. So energy is what the E stands for. The M stands for mass. And the C is the speed of light, which is a big number. So if you square the speed of light, you have a huge number. So really what that equation is saying is that you can turn even a small amount of matter into a very large amount of energy. So when we have this nuclear fission, what Lisa Meitner had figured out is that a tiny amount of matter is turned into quite a large amount of energy. And she also figured out that it spits out a neutron when you split that nucleus. And if you can get that newly spat out neutron to hit a different uranium nucleus, then you can make that one also split, sending off a neutron that can split another one, sending off a neutron. And basically you can set up a chain reaction. And that chain reaction can create enough energy to either power a city or level one. So basically, Lisa Meitner said it is theoretically possible to build superweapons. Or, solve our energy problems. Both of those potential things that you can do with this technology. Yes?
So when Otto Hahn was doing the experiments, wouldn't it make a big explosion?
This is on a very small scale. So it does create a lot of energy, but it wasn't creating you have to have pounds of uranium to create a bomb. Yeah.
Is that what's in the atomic bomb?
What's that?
Is that what's in the atomic bomb?
Yeah, uranium.
How do you spell that?
Uranium. U-R-A-N-I-U-M. Uranium. Which is an element with 92 protons. And we do a very quick bit of math. 238 minus 92 is 6. Anywhere from 143 to 146 neutrons, depending on the isotope. An N with a 0 up here is my abbreviation for neutrons, just so folks know. So that's the state of things when we're moving forward. And I don't know if I got to this with y'all yesterday, but the Nobel Prize Committee actually does write to Otto Hahn and is like, hey, we'll give you a Nobel Prize for this. And Otto Hahn fully takes the credit, does not give credit to Lisa Meitner, and just takes the Nobel Prize. I don't know if I got to that part yesterday, but that is what ends up happening. So Pierre Curie fought the Nobel Prize Committee when they were going to give... So Pierre Curie fought the Nobel Prize Committee to make sure that Marie got the prize. Otto Hahn doesn't fight for Lisa Meitner. He just takes the money.
Bad thing he did, but at least it was nice of him to give his mother's diamond ring so she could get out of Germany.
Yeah.
Kind of crazy.
next individual. We're going to talk about Niels Bohr. And again, these people all know each other. Here's a picture of Niels Bohr kicking it with Einstein. There you can see him as a young man. He's a Danish physicist, also Jewish. You'll note that, like, actually kind of a disproportionate number of these nuclear physicists are Jewish. It's just like an area where they found community. Question?
Did Niels Bohr and Lisa Meitner know each other?
Yes, almost certainly. So he is a Danish physicist. He is living in Copenhagen, which is in Denmark. And in the early days of the Nazi regime, he actually houses refugees from Germany. Right? He's got his like Institute for Theoretical Physics, and he's taking in people who are fleeing and like giving them shelter and taking care of them until they can make their way out farther away. Now he is most famous for something called the planetary model. And the planetary model is actually the model of the atom that we're going to use when we study chemistry. Because it's really, really incredibly useful at explaining why atoms behave the way they do in chemical reactions. And in the planetary model, so where we had been with Ernest Rutherford discovered that there was a nucleus at the heart of the atom that's positively charged. It's made out of protons and neutrons. And then most of the atom was empty space. But Rutherford doesn't really explain where the electrons are. So what Bohr is basically adding is he's adding information about where are the electrons in this model. And what Bohr says is basically you can think of there being like these energy levels. Sometimes they're referred to as electron shells. And basically they're like, think of them as like orbits almost around the atom. And the electrons first go into the ones that are closest. That's like the easiest place for them to be. But there's only a certain number of electrons that can be in that like innermost ring. And once that's full, then electrons start moving into the next ring out. And when that one's full, then they move to the next ring out. And as you go out, you can hold more and more electrons. This model is incredibly useful because it actually explains valency, which, if you'll recall, there were like certain groupings of how elements behaved that was referred to as valency. And once we get this model, we know that the valency is actually how many electrons are on that outer edge of the atom that actually get to interact with other atoms. And that's why things with the same valency behave the same. It's because they have the same number of electrons in the outermost electron shell. So that's the planetary model. We'll go into way more detail on the planetary model once we actually start our study of chemistry. Now, Niels Bohr is a friend and mentor, like he literally taught and helped bring up this German physicist named Werner Heisenberg. Now, Heisenberg is not Jewish. He is German. And I don't know if you've noticed this, but a lot of the people we've talked about have been Jewish. And, of course, they're all fleeing Germany. So folks like Einstein is a German Jew. He leaves, right? He flees to America. So Germany has kind of, because it has this deeply ethno-nationalist, like narrow idea of who gets to do things, who's allowed to be in public positions, they have effectively driven out a large number of their most capable people. This is what happens when you're racist or sexist or, you know, anythingist, is you end up cutting off your ability to have access to like the full skills and capabilities of your population. It literally makes you worse at your job if you're going to do that. So Germany has like lost a bunch of its physicists, but Werner Heisenberg is not Jewish, and so is still like one of the few people who is doing nuclear physics in Germany at this time period. And important to note, he and Niels Bohr, who is a Jewish physicist who was his mentor, are tight. Right? They are close friends. Again, all these people exist in community with each other. And now they find themselves on opposite sides of this war. Now, after Lisa Meitner's work, when folks have realized it is theoretically possible to build a superweapon using a chain reaction of splitting uranium atoms, it's possible to build an atomic bomb. And how to do it is just an engineering problem. Suddenly, all these major powers are setting up nuclear programs to try to do this. So in the United States, there's this thing called the Manhattan Project, which is going to invite a whole bunch of scientists from Europe, but also kind of an entire generation of American scientists, just like thousands of American scientists are gathered up and brought to like secret facilities in the middle of the desert where they're going to be working on this super weapon. And a lot of them are like effectively disappeared. Like a whole bunch of physicists just kind of go missing and suddenly are doing something secret in the desert somewhere, and no one knows what they're up to.
When is this?
This is in the 1940s. And Niels Bohr has received an invitation to work with the Manhattan Project, which is this American project to build a bomb. And the Nazis want Werner Heisenberg to work to build them a nuclear bomb. These two are close to one another. Werner Heisenberg travels to Denmark, and he meets with his old friend Niels Bohr in a cafe in Copenhagen. Now, the fun thing about history is we weren't there. And nobody was sitting there with a recorder. Nobody was there with their cell phone filming this conversation. We don't know what these two actually said to one another in that conversation. What we have access to is the things that they said about it later. We have access to like them writing about this conversation in their, journals and letters and diaries and things. And what Werner Heisenberg says, so Werner Heisenberg is the German, is he says that these two had a conversation about it, and they both agreed it is possible to make this, it is incredibly dangerous, and this is a technology that should not exist.
Okay.
And that it's the moral duty of scientists to not build something like this.
So Heisenberg and Niels Bohr had a conversation.
They have a conversation.
And basically to create, they realize they can create the atomic bomb. But
They know they can.
But they don't think that anybody should.
Heisenberg says in his letters that what the two of them said was, neither of us should build this, right? No one should build this, and especially not us. And Heisenberg will then go back to Germany, where he will tell Hitler, there's no way to do it. It would cost too much money. It's, practically infeasible. Can't be done. There's just no way that this will ever actually happen. And effectively, Heisenberg goes back and throws sand in the gears of fascism. He works to slow everything down, to make it seem like it's impossible, to claim that this cannot be accomplished. And that's what Heisenberg does. Now Niels Bohr accepts the invitation, goes to America, and helps us build the bomb.
Oh, so
He just betrayed his friend.
We don't know, because we don't know what they ever actually said. Right? All we have is what they say about it. So, and what they claim is different. Niels Bohr doesn't say, I agreed that I wouldn't go help the Americans. But Heisenberg says, we both agreed that we would not build this. That building a superweapon was wrong. Right? And I do think it's important to tell the stories of people like Heisenberg, because it's important to understand that even if there's a difference between governments and people, right? You can have an evil government and have normal, regular, human people like Heisenberg, who when Heisenberg thinks of Jewish people, Heisenberg thinks of my mentor, my teacher, Niels Bohr, right? To Heisenberg, Jewish people are people and his friends and his community, and not this dehumanizing propaganda that he's been sold. And that's part of why, even though he's still living and working in Germany under Nazi rule, he spends that time working to slow down and prevent the Nazis getting their hands on something incredibly scary and dangerous.
and Niels Bohr recommend that the Manhattan Project didn't make the bomb.
It helps us make the bomb.
Yeah.
Yeah. It's important to note there's a huge number of physicists who come work on this. If you were a physicist, and this ranges from like really famous people, like Lisa Meitner's getting invitations, Niels Bohr's getting an invitation, Einstein's getting invitations, like all those famous scientists are getting invitations, but also like random grad students who are like just out of college. An entire generation of physicists is basically like sent away to these secret labs to work on it. Yeah.
How long did it take them to build it?
Years. Now, y'all remember the Exploratorium?
Yeah.
The guy that built that museum, he was a physicist, and he worked on the Manhattan Project. There's a huge number of people who worked on it. It's a massive group project.